For this week's class, I read a case study on the Nokia Internet Pulse project. The paper described the attempts of the research division within Nokia to develop an application to visualize the sentiment of tweets regarding Nokia products. The project combined three cutting-edge computer science topics: 1. Social media, 2. Machine learning-based sentiment analysis, and 3. Big data visualization. On the social media aspect, they used Twitter. They used the Twitter API to download the source data. For the machine learning, they applied very basic sentiment analysis rules to classify each tweet, ranging from negative to positive. And then finally, on the big data visualization side, they attempted to depict the overall sentiment of tweets for a time range relating to specific Nokia products or topics on a big board style display, such as a large monitor or alternatively small monitors in elevators. In my opinion, the most striking aspect of the project was the vast expenditure in terms of both time and human capital and the low return on the investment. It appears that the project involved several senior researchers for several years and yielded a non-commercial product that currently has no web presence, and this is less than 3 years after its public launch. For a product with that sort of investment, that almost certainly has to be considered a failure. What can we learn from this project, though? It's easy to criticize failed projects retrospectively, but we want to learn something that we can use in the future. Let us consider one aspect: truth, or if you prefer, correctness. Big data, very much like statistics, can be manipulated, misinterpreted, and misunderstood. Unlike statistics, however, there are currently no standard means of ascertaining correctness. In this, I mean, where in statistics you might have data that you feel is flawed, but you can take a look at things like the standard deviation, or you can look at statistical significance to see if there's something that indicates where the problem is or that can confirm that the data is correct. In the Nokia project, there did not appear to be any way to drill into the data, and this I felt was a significant factor in how the application failed. Because there is no way to drill into the truth of the data to see and correlate what the overall conclusion, so a bright green marker attached to the latest Nokia product couldn't be directly connected back to the tweets that produce that bright green marker. So in effect, you don't know the truth of the data, and not knowing the truth of the data is a significant problem. Another example, a specific example, is in one development iteration of this project, they incorrectly tagged tweets with the word new as positive. This is problematic since you're attempting to ascertain how well people like your new products, and so many tweets are going to say things about the new products. Specific problems, I think, though, that get back to our truth question. One, it indicates that they probably didn't use much machine learning. Even a simple bag of words technique with some decent amount of training data probably would not have had this problem. It implies that they used some sort of regular expression-based rules, which are unlikely to ever reflect the real world without way too much work. The second thing that's problematic is they required a code change to change the classification of a single data point. This gets back to this idea of truth and connecting the truth of a data point back to the user interface. I think it's important for any system like this to have a feedback mechanism. So, for example, Google can use which links have been clicked to ascertain how good a match a specific result is. So if, for example, you search for St. Louis Cardinals, my favorite baseball team, and 5,000 of the clicks out of 10,000 go to the first link, and then there are 1,000 clicks on the 3rd through 7th links, Google can effectively demote the second link because nobody clicked on it. In the system that we looked at, you can't do that directly, but what you could do is have a way of drilling into the positive and negative aspects and then allowing the user to correct, maybe even having like a sliding scale that says, you originally classified it as positive, very positive, but instead we're going to classify it as neutral. And so then having that reflect back on the the original classification. I think such feedback systems help in two ways. One, it improves the quality of data, and that's always a good thing. And two, it improves the perception. Users who can correct false data are more likely to believe the visualization of all of the data. And this essentially is what we are getting at. And this is where this fundamental question of truth in both our data and our visualization, I believe, is one of the keys to big data visualization.